Thank you, everyone, for coming to the mobile theater for today's session. Lessons learned, building a hybrid remote app with communities and Ionic. My name is Roger Mitchell. I'm a senior project manager and development team lead at Arcus Inc. We're a consultancy based in New York, offering Salesforce implementations, integrations, custom UI, pretty much anything that's on the platform we can do. If you want to reach out to me, I'm at Roger Mitchell on Twitter. So today we're going to look at a few things. First, we're going to start off with some intros and definitions around what is mobile with respect to Salesforce. Then we'll dive into a use case that we had with one of our clients and talk about the technologies that we decided to select. We'll then take a look at three different lessons. The first is animating UI transitions and how a hybrid code base can produce different results when you're actually testing on device. Then we'll take a look at how we manage request volumes to prevent memory issues and app crashes, which are terrible. And then we'll dive into testing the waters as a QA or as a non-engineering user and talk about how you go through a process of publishing betas internally and getting feedback from stakeholders. Also, it wouldn't be complete if we didn't do some hindsight 2020, so we'll take a look back and see what we could have done differently and also what we're going to do forward in the next few months with this particular client. So with that, let's first dive into some definitions on what is mobile. So you might be here and everything is mobile ready and you can roll out anything you want to your businesses, and that's partially true using the Salesforce One mobile app, which is available on the iOS and Google Play stores. Now, this does allow you to roll out these really great experiences. You can do declarative development with publisher actions and Lightning experience. But what it doesn't allow you to do is publish out your own mobile app with your own branding and really control the whole suite of the APIs that devices offer to you. So Salesforce has this really cool thing called the Salesforce Mobile SDK. And the Mobile SDK allows you to do development in iOS and Android and tie into the REST APIs, encrypt your data when it's at rest on the device, and also handle syncing if you're offline and you're coming back online, and you need that data to flow back into your Salesforce database. Now, when we talk about mobile, there's also three different patterns. There's native, there's hybrid, and there's HTML5. So let's start on the native end. If you're looking at something like Airbnb, which has really slick transitions, it has paradigms around the user experience that are tied to that particular device, such as side menus and how you handle trays. That's all done using native code. So you're developing it in Objective-C or Swift for iOS and Java on the Android side. Now, this is really great if you have very, very precise requirements around how your user interface interacts with the user, or if you need to tie into a specific sensor that device offers. It does also require really specific talent. So you can't just take someone who's really good at web dev and throw them onto an iOS or Android project. So the sweet spot in the middle is hybrid, and there's two flavors, remote and local. Now, what this is basically doing is taking a web application that you deliver in HTML5, JavaScript, and CSS, and it's either transpiling it into native code, which is hybrid local, or you can take it and host it as a resource, in which case it's really just like a web browser that you're deploying out as your app, and it's serving the content from some server. And then finally, the other side, which is HTML5, this is the least mobile we could think of. And it's basically not downloadable as an application, but it's that responsive website you might think of from about 5 years ago when Bootstrap came out. If you drag the menu bar across the top, suddenly you see a little hamburger icon appear and things reshuffle on the page. Now, there's a lot of work being done in this area, especially around progressive web apps, which we're not going to cover today. But it is potentially going to morph into something completely new. So you don't have to build something and deploy it out via the iOS and Android developer routes. So let's talk about this use case that we had for our client and how we decided to pick Ionic and Communities Cloud. So here's the use case. We have some young adults that are traveling to a foreign country, and this organization wanted to capture all the things that happened after that trip and surface content from their partner affiliates and their own organization within this privatized application. Now, they want people to be able to share their experiences not only in the community and via the app, but also send it out via email or SMS. And they wanted to curate content using RSS feeds. So if a person or an organization were to throw an RSS feed in, it automatically starts to publish content within the application. So for this, we started with customer community. Now, we did this because all the contacts that are going on this trip are already captured in their Salesforce CRM. And we used a partner community as a separate route for the content affiliates to publish content and create their RSS feed subscriptions that would ultimately drive the app's content. So 2 different communities, one is mobile focused and one is desktop focused, to really create a great experience for the constituents. Obviously, Communities Cloud is built on top of the Salesforce platform, so all the data we have, all the content, anytime a person likes or shares something, is all captured in objects within Salesforce. And on top of that, we're using the Chatter set of APIs to do collaboration around comments, liking, and following and friendship. And finally, for the mobile piece, we decided to use Ionic Framework, which allows our developers to write just standard web apps and transpile the code into native iOS and Android source code. So we talked a little bit about why we want to use communities. Another sort of factor here is the fact that the organization already has existing Salesforce talent. So if we were to go find another communities product or something else and home build it, they might need to augment their staff resources in order to maintain it over time. And that's not something that the organization wanted to do. Also, we don't have to support them as a partner. We can actually hand over all the code, and they're able to make changes on the fly to their mobile app and for their constituents' experience. And in terms of why we decided to use Ionic Framework, it allowed them to use the existing web development team that they had to make those changes that they see fit. Ionic Framework is going into its version 2 beta right now, as Angular, Google's JavaScript framework, is also going into version 2. So it has good maturity. It doesn't require that learn once, write everywhere pattern that React Native has. And also, we didn't have to learn C# to do Xamarin. Now, why we chose hybrid remote, it was actually pretty neat. And during the demo, I'm going to show you how I can change out the app experience using static resources, because all of our content is bundled. And I can just throw that up into a static resource, and then we have a new experience without having to go through a push upgrade through iOS or Google Play. So our first thing is animating the UI transitions. Now we see here we have Federico. Federico is a user of this application. And we have a side menu that's slid off to the side there. And what we were trying to do is figure out a way to make that really buttery smooth across any device, both iOS and Android. And what we were finding out is that as we did development, we were writing all this in JavaScript, CSS, and HTML. And we were testing in browser. And when we got to some internal testing after one of our sprints ended, we started testing on the device, and we saw the performance of that slide was absolutely terrible, and it really needed work. And as a user of it, I felt the pain that I knew other users would feel if we were just to ship that. So we decided to step back and think about how we could approach this in a different way. So the first thing we did as part of our refactoring is use JavaScript. And you might think, well, that's crazy. Why would you use JavaScript? And you're absolutely right. It's a terrible idea. Don't do it. But we did try it because we wanted to see how many different things we could do in order to make this a really great experience for the user. So what we're showing here is we're starting off with the menu being displayed. It's not being displayed at that time. And we're grabbing the content wrapper, which represents this portion over here on the right, which is our sliding feed view. And what we're doing is, if it's going to push to the side, we actually grab the position, and we slowly move it over there using JavaScript. And similarly, if we want to bring that menu back, we're doing a separate hide function to accommodate that. Now, what we found is that this is a suboptimal experience. While it is very consistent and the transition is basically linear, it doesn't really feel good as a user. And it also really hits the device's CPU super, super hard. And that's going to cause an issue with the application and how it performs. If you're already doing background operations and then you do this transition, you could potentially crash your app. And your user is going to have a really bad experience. So we tried another alternative, which is using CSS. Now, it's interesting. We're using the transition ease in out, which is something you might be familiar with if you've done website design or if you've done some Visualforce pages with animation. And the transition is good, but there's a few things that happen. It's inconsistent. So as you start to move that menu, it'll start to be jittery if you're having some load on the application already. And on top of that, we're not actually offloading any of this responsibility from the device's CPU to the GPU, or graphical processing unit. Now, that's fine in most cases, and we're going to see it works really well when I show it to you. But then as we start to load content, we start to scroll, and then we click, it's going to be jittery, it's going to be awkward, and create yet another bad experience for our user. So we arrived at the best solution, which is still using CSS, but instead of using transition, we're using transform, and we're using the translate 3D function. The translate 3D function, when it's operating on the device, is offloading all of that responsibility to the device's GPU, therefore leaving the CPU open to do background operations or whatever else you need. Also, through very thorough testing, hours and hours of testing, we never saw this thing become jittery or do anything awkward for the user. So this is how we feel like we can deliver a really great, buttery, smooth experience. So let's take a look at these three different approaches and see which one pans out the best. All right, perfect. Can you guys still hear me? OK, great. All right, so let's dive back into this. So what I've done is I've gone into Firefox. I've loaded up a static resource that has our CSS. In this case, it's going to be the first CSS, which is using transition, ease, and out, as opposed to transform 3D. So within Xcode, I'm going to go ahead and serve up this app. And we're loading up some data here. So what's happening is we're pulling in a bunch of content. And when I go up and click on our hamburger icon, you see it's OK. It's a little bit jittery. We could probably get away with that. So I'm just going to be jumping back and forth here. And one of the interesting things that we can see within Xcode is right now we're operating around 4% of CPU. When I start clicking this, we're spiking our CPU up to 60, 70, even sometimes 90. And that's because we're using the CPU to handle this transition. Now, if I start to scroll, so let's do a little scrolling here. Let's go grab some more content. Got a lot of great content here. We've got some bacon. When I click on this, it's really, really bad. It's a very awkward transition. So that's not going to cut it. Let's try our JavaScript route. So I'm going to go ahead and stop our simulator. I'm going to hot swap this static resource using a different zip file. So I'm going to go ahead and edit this. I'm going to grab my badjs.zip and go ahead and upload this. And once it's uploaded, I can reserve the application into our iOS simulator. And we're now going to have a completely different transition. So make a note of that. If you're interested in hybrid remote, this is a really, really neat pattern because we can dive back into the application and the experience is completely changed. That's not only true of transitions in your CSS. We could roll out a completely different experience to this Visualforce page effectively, which is in our iOS device. Now, that's pretty bad, but at least it's consistent. Now, I'm hanging here for half a second as I'm sliding back and forth. And as a user, that might be really cool as I slide my thumb out and slide my thumb back in. But imagine you're trying to do that a few times when you're using the app. You're going to start to get a little bit frustrated. So our final example is using our current code base, which is leveraging the CSS that's doing a translate 3D. So let's do good current. And we're going to hot swap that in. And once we upload, we'll see that we have a much better experience for the end user. Also, we're going to see our CPU is never really spiking above 15%, just due to background operations that the application is doing. So we're popping in here. It's loading up our content. We see our CPU is spiking as we grab some data from the Salesforce server. We're back to a steady state around under 10%. And this transition is beautiful. It's nice and buttery, and my CPU is not spiking at all. We see our CPU graph is relatively flat. It's staying pretty stable. Now, the other test we were doing is if we start to scroll and we start to make a lot of requests. Because as we scroll down, we start to request content from the server. And if I click on this, it's still buttery smooth. Nothing's happening. So let's go ahead and dive back into our presentation. And we're going to take a look at this one more time. Whoops. All right, so let's jump ahead. Here we are. So by using transform and the translate 3D function with that, we're getting a really buttery experience, and we're not seeing any lag for the user. All right. So let's moving on to managing request volumes. So as an application, we're not really on MacBook Pros. We have iPhones or Android devices that have lower memory. And one of the things we need to be cognizant of is the background memory that our app is consuming with any content that it's storing, especially photos or video content that we're pulling down. Now, as we were scrolling, we got to see that we're requesting more content and more things were loading into that feed view. And as that happens, we're not actually destroying it. It's just persisting in the application's memory. So what we had to do is basically create a poor man's garbage collection. So by using services in Angular, we're able to request a bunch of content that fills each feed if we were to swipe between feeds, but it doesn't fill it with a lot of content. It pulls down, in our case, 40 items per feed. And as you start to scroll down, if we get to that threshold, we're going to start to make a request to the server to get more data back. And as we do that, if we exceed a certain point, we start to throw out the data that's at the top of the feed and only keep 40 items at any given time. Now, the way that this works is we have an Angular controller that is basically grabbing all the data from Salesforce and storing it in services. And as our view changes, it's using the controller to serve up different content and iterating across that to make those cards we see in our feed. So most specifically, it's a little bit hard to read, but we'll post the slides up on the session. We're taking a look at this multiplier as 0. And if our list length in the feed has more than 40 items, we start to shift that downward, effectively removing the top item. So as an example, if we had 50 items, we're going to shift the top 10 out. And the second part of this code here is basically handling the infinite scroll. So if we keep scrolling and keep scrolling and keep scrolling, and there's no more content, we don't want that little spinner to be down at the bottom because that would be a weird experience. The user's left hanging, and they think something's going to happen. So with this, we're basically killing off our infinite scroll, and we're stopping the request to the Salesforce server. So let's go ahead and load up a different static resource here. We'll load up one that does not have our garbage collection, and we're going to see our memory actually starts to expand as we are navigating through the app. All right. I really love that hot swapping. It is so cool. All right, let's make that a little bit bigger for us. So we see on the side here, our memory is around 133, 210. And as we start to scroll in this feed view, we're going to see the memory continue to grow. We're at 328, 330. Now you'd think, OK, well, that's not very big. We're still in the green by a fair margin. But we're also looking at this as an iPhone 6 Plus, which is a relatively new device. In order to support users, especially on the Android side, which has more device fragmentation in their ecosystem, you have to be willing to accept different experiences. And some devices don't actually have over a gig of memory. So you can easily crash this application when you have other things running on the device that are consuming background memory usage. Now, as we keep going, we're going to continue to see our memory grow. And as we go between our feed and our likes, we're basically continuing to surge that memory. So with our poor man's garbage collection, we're able to handle only 40 items in a given feed and shift that content out. Now, whenever the application loads, we're always retrieving back the newest content and always keeping 40 items in every single feed. Now let's talk about the last thing, which is testing waters as a QA. We talked about earlier how when you're doing this hybrid development, you're probably testing in browser, and your browser's not going to handle things the same way that devices will. And also, you'll end up seeing weird things like CSS produces a completely different result if you use one selector versus another selector. And if we look at this, we ended up having to do a lot of our testing on device, either in the simulator or by plugging our iPhone or Android device into our computer, simply to get this sort of profiling on the memory usage, the CPU, what's happening with the network. And as a QA, you should also be considering the fact that we're on really good Wi-Fi, or in my case, I'm on Ethernet right now. But most mobile users are probably on LTE, or they might degrade down to 3G, or even offline in some cases. So how does your app handle those different speeds, and also the inconsistency of speed? So if you go from an LTE connection while you're requesting data down to a 3G connection, and then degrade down offline, is your application going to continue spinning, or are you going to handle that somehow in the UI and tell them that the app is now offline? And for testing with non-engineering users, both iOS and Google offer really great options for testing. So with iOS and the Apple Dev Program, you can use TestFlight to have them install an app from iTunes, and you push out like a sandbox version of your application so they can dive in and start doing testing and logging feedback. On the Google Play side, it's even more seamless. They can just go into the Google Play Store, and as long as their email address is registered, they have an application available to them to install, just like every other app on their phone. So let's look back and let's look forward and see what we could have done differently and what we're going to do now. Now, what we found out is hybrid is really awesome if we are using a single code base and we're trying to be really lean about our development. But it also creates a different experience when it gets to be around native device API connectivity. So we're using a lot of plugins to do things like photo uploads and access the camera roll. And that has its own set of nuances. Cordova plugins are either really well documented or they're terribly documented. Some don't work anymore, but you can still use them and end up spending hours just trying to refactor. So something we could have done differently is do this with React Native and write it for each device format, and basically transpile it down into Objective-C and Java, as opposed to doing it the way we did with Ionic. We also might use a different backend. Since we're storing views and we're storing all the shares, if a person shares content about 15 times to 15 different friends, that's 15 different records in the database. And at some point, that data storage is going to add up, and you're going to have a real problem on your hands. So something we could do is also use Heroku to handle the data for the application, the content, and then surface the analytics through an object or Heroku Connect or some other backend process to provide that level of reporting that the client needs. And looking forward, we're basically starting our exact target marketing cloud piece. So we're handling all of our email and push notifications through Apex right now. And you have some pretty severe limits in terms of what you can and can't do within a 24-hour period. Although with eTMC, you can push out that content as much as you want. So we're looking to not only send our emails out that way, but also do push notifications based on content, likes, and whatever else. And we're going to start using geolocation, which is another feature of the exact target marketing cloud. So if a person walks into a certain event, they get a push notification that 3 of their friends are already there. We're going to start working on social integration so people can share that content more easily via Facebook and Twitter. Do recommended content using an app exchange app called Coveo. So if a person likes a lot of things that are food related, or they like a lot of things that are holiday related, we can end up surfacing that content into their feed, as opposed to just showing them generic stuff that everyone else is looking at. And finally, we're going to be at a point very soon where we have around 4 months of usage data. So we can go back in and see which features are actually being leveraged and which features aren't, and help prioritize the client's roadmap with respect to what they're going to do next. So if something is not being used, you can just basically throw it out from the application. And if something has a lot of use, but we're not getting a lot of feedback, we might want to figure out how to bring that into our user experience discussions and talk through users about how they could use it differently, or if there's an alternative way to do that. So with that, thank you guys very much. If you have any questions, I hopefully have some answers for you. Are there any questions? Or you can see me after. Awesome. Thank you.